Hello everyone. So this problem is from GATE examination of the year 2019, and this is a problem from quantum mechanics, and this is mainly from the perturbation problems. Okay, so let me state the problem first. The wave function psi x of a particle is as shown below. You can see the wave function given. So here k is a constant and a greater than d. The position uncertainty delta x of the particle is, so the four options are given. So let me just try to solve the problem. So this distance in the diagram is d by 2 because the whole distance is d. Similarly, this distance is d by 2. So I can say that this point should be, this is a by 2 and this is d by 2. So the distance between these two is half of a minus d. And so similarly this part also, I think it will be easier to write it in this side. So this side the distance will be half of a minus d, and the distance, this total distance should be half of a plus d. So similarly here also, this total distance should be half of a plus d. So the coordinate of this point would be minus, okay, let me write it down here. So the coordinate of this point is minus half of a plus d, whereas the coordinate of this point is minus half of a minus d. Maybe the coordinate of this point is half of a minus d, and the coordinate of this point is half of a plus d. So this is the diagram I have. So I can write that from the given graph we can write the wave function as psi x equals k for, so for the first part you can see from the shaded regions, in the shaded regions there will be the existence of the wave function, okay, in this part. So this should be from minus half a plus d to half, or rather minus half a minus d, and from half a minus d to half a plus d, and the wave function is 0 otherwise. Now this wave function should also be normalized, right? So let us now normalize this wave function. So the normalization condition is integration. So let me consider mod n as the normalization constant. So that should be the mod chi square dx equals to 1 in the whole range. So I can write it down. So this will give me as of n square. Now psi is given as k, so it will be k square. And the integration can actually be divided into two ranges because the wave function distinctly stays in that two range. So it is from first integral is from minus half a plus d to minus half a minus d over dx plus integration half of a minus d to half of a plus d dx, and so now this should be 1. So I can see mod n square k square. So it is x. The range is from minus half a plus d to minus half a minus d plus x. The range is from half of a minus d to half of a plus d, and the whole result should equate with 1. So next step, it is modulus of n square k square. So the first value will be put. So that is let me take minus half as common. Then it is a minus d. Then minus 9 of this. So plus half a plus d. Then here also half of a plus d minus half of a minus d. So this will be 1. So this will give me n square k square. These two will give me a plus d minus of a minus d. So minus a minus plus a will be cut down. So I will get modulus of n square k square times 2d equals to 1. So this will give me modulus of n square equals to 1 upon 2d k square. Okay. So this is the first thing we need to find. Now let me go back to the question. So in the question they ask the position uncertainty delta x of the particle. So in order to find the position uncertainty, so the position uncertainty delta x is defined as delta x equals to put under expectation value of x square minus expectation value of x whole square. So we need to find two quantities. First one is the expectation value of x square and the second one is expectation value of x. Now from the graph, it is clear that the wave function is symmetric. I think that there is a spelling mistake. Symmetric about the origin, that is x equals to 0. Okay. So we can directly say that expectation value of x equals to 0. Right? So our job is to find x expectation of x square. So now expectation value of x square equals to mm, modulus of n square integration uh, modulus of psi square x square dx. So it will give me n square. Now the psi square would be divided into two regions separately. The first one is from minus half a plus d to minus half a minus d plus integration a square x square dx over half of a minus d to half of a plus d. So it will give me modulus of n square k square into, so integration x square dx will give me x cubed by 3 in the range minus half of a plus d to minus half of a minus d plus the second part is x cubed by 3 in the range half of a minus d to half of a plus d. Okay. So it will give me then modulus of n square k square by 3, and x cube will mean that it will be minus 1 by 8 a minus b whole cube, then minus of minus 1 by 2 whole cube, so that will be plus 1 by 8 a plus d whole cube, then it will be plus 1 by 8 a plus d whole cube minus 1 by 8 a minus d whole cube. So let me just put the value of modulus of n square, so which is 1 by 2d k square. So I can write 1 by 2d k square times k square by 3. Right? Then there are two pairs of terms. So let me take 2. Then I can also take 1 upon 8 outside. So then the a becomes a plus d whole cube minus a minus d whole cube. Okay. So these two and these two will also be cancelled. So this will give me 1 upon 24d. Now this thing will give me a cube plus d cube plus 3a square d plus 3a d square minus of a cube minus d cube minus 3a square d plus 3a d square. Right? So this a cube and a cube will be cancelled, as well as this 3a d square and 3a d square. So it will give me 24d times 2 into d cube plus 3a square d. Right? So d can also be taken as common. So it will be 12. So 1 upon 12d into d common if I take, then I can write it down as d square plus 3a square. So it will be d square plus 3a square by 12. So that delta x is root under 3a square plus d square by 12. So let me check the options. So option B would be correct. So thank you.